My name is Vance Shipley. I'm the CEO and founder of SigScale. We're an open source software developer for the communication service provider business. We have joined the 5G Chargers Catalyst with a focus on converged charging. The converged charging system in 5G, which brings together the online charging and the offline charging, the decomposition of the functions within it are described in 3GPP-TS 32.296 and are depicted in this diagram. So the main things that we have here are the charging function, the rating function, and the account balance management function. So we're going to be talking about those for the rest of the presentation. The charging function is network facing. It terminates all of the network specific protocols, the 5G, NCH, and the evolved packet core, diameter GY, IMS, diameter RO, and even the cap for the 2GCS, for instance. And we'll talk more about the RF and the ABMF. If we map this to the ODA components, the ODA architecture, we can consult IG 1242, which provides the current inventory of the components that are going into the ODA reference implementation. The two that we come out with are product rating and service balance management, and those have a one-to-one mapping. So product rating is a rating function, and service balance management is an account balance management function. And you'll note that they are in two different blocks of the functional architecture. So product rating is a core commerce ODA component, and the service balance management, or ABMF, is in the production block. The main premise of the work that we've been doing in this catalyst is to have a catalog-driven solution. And so that means that we should have a single authoritative product catalog where we define the commercial rules and policies in a single place. Now, that information obviously needs to be reflected and used by the other components in the system. So the converged charging system will be directly driven by product offer prices. So there's no separate provisioning putting prices into the CCS when you change prices. The prices are updated, the product offering prices are updated in the catalog, and they are reflected automatically to the CCS. And that's kept in sync with OpenAPI notifications. And then another part of what we're doing here is the product offering price has always been able to define a pricing logic algorithm that is used for more dynamic and extended pricing models rather than a simple unit rate, which could be contained within a pricing product offer price. So the pricing logic algorithm in the catalog is providing a reference to an external rating function, and that fits very well for what we're doing. So again, the important thing is if we're going to make changes to our commercial offers, that they can be done just in the product catalog, and those updates are reflected and used. So the information needed to do this, the converged charging system will maintain a reflected cache of select data, not all of the data. So you see here product inventory. That's not a copy of the product inventory. That is it's an internal store that includes information collected from the product inventory. And same with service inventory, product catalog. So the CCS is subscribing to notifications so it can learn of the changes that it needs, and then it extracts just the information it needs and inserts it in the way that it needs to. So when subscriber usage comes along, arrives at the CHF, it will use the subscriber identifier to locate it in the service inventory and then navigate through the rest of the information model to get a list of product offer prices that are applicable for this usage by this subscriber. So the next step is that the CHF will need to filter out the prices that don't apply. So firstly, if it's data usage, then a voice or a messaging product offer price wouldn't apply. So we can strip those out. If the price type is a one-time recurring things like a subscription charge or an installation charge, obviously those can be stripped out as well. So we're going to filter down to the rates that apply for the type of usage that we have. Now beyond that, and you'll see in this example, we have two prices that are left, one called internet, one called gaming, and they're both data prices and we have data usage. So the next thing that's used is that a policy and charging control framework, which is a 3GPP framework, other network elements like PCRF are responsible for that. But when the usage request will arrive to us, the service usage information is tagged with a rating group, which can help us, and the purpose of it is to be able to determine how to apply rating. And so we will discriminate the product offer prices that are left based on the rating group. And here we show how that is done using a product specification characteristic. And so we see that the value 32 appears, and that identifies that the price to use is the gaming price. So beyond that, in the use case number 3 in our catalyst, Oracle and SigScale have teamed to demonstrate the decomposition and the use of a remote rating function. And so here you'll see that at the CHF, we've now identified, we're going to use the product offering price named gaming. And the CHF will now look at the pricing logic algorithm attribute of the product offer price, and it will see that there's an external rating function identified, and he provides where to find it in an href. And so the next thing that happens is that the CHF will send a tariff request to that rating function or product rating component in ODA, and the result of which will be a tariff. Now, that tariff isn't the end price. That tariff is in providing the unit determination and the cost per unit that we can use for ongoing pricing. So that this request only needs to be done at the beginning of the session, and then as long as that tariff remains valid, and it may have an expiration, in which case we need to go back and ask for another one. But as long as it remains valid, then we continue to do the charging without having to consult the rating function again. And so then the charges are calculated by the CHF and applied using the APMF. Now, interestingly, in a lot of policy and charging control scenarios, you'll actually have multiple rating groups in use on a single data session. So a subscriber has their smartphone and they're using it simultaneously to do a number of things, because what they're doing and what the apps are doing are all happening concurrently. And so the service usage that is provided in the request will likely contain more than one rating group. See, in this example, there are 2. So we see rating group 32 for gaming, and we see rating group 10, which was general internet access. We might have other rating groups that were for 0 rated because it's for the self-care portal or the data bearer for IMS, etc. So the different product offer prices will be matched to different components of the usage within the same request. And so we see that example here where the Oracle RF is being used for rating group 32, and the internal RF in the SigScale CCS is being used for rating group 10. One of the contributions coming out of this is about the API that we used to connect SigScale and Oracle. So the rating function provided by Oracle is in another ODA component, and we need an API to be able to communicate the tariff request and get a response. And so we developed that API, and the evolution of that is depicted here. So we began with the decomposition architecture that 3GPP defined, and in 32.296. So the RE interface is the interface between the CHF and the rating function. Now, in that specification, it was really for 2G, 3G, and 4G, and it was specified as a diameter application. So today we need something more than that. 3GPP have yet to define an RE in the 5G context, and they may not, because they may consider it out of scope, but it's certainly within scope for the TM forum. So what we've done is we modernized the RE interface by using the 5G service-based interface drafting rules, and we merged the data schemas coming from the 5G Converged SPI, so the SPI from the network to the charging function. And so we merged those together, and then that created a 5G SPI-like API, which we then mapped towards the TM Forum Open API program. So we've mapped that using the TMF 630 guidelines, and we've come up with a proposal for an experimental API for the product rating ODA component.